मैं लाइव जा रहा हूँ।
Hello everyone. We are basically today we have a very important topic, and which was a recent development addition by AWS services. What they have done is basically added container support to Lambda functions. First of all, we have to understand what are the implications for this decision and this advancement. In a normal Lambda function, the size, it basically uploads a zip file, and there's a restriction of 250 megabytes on that Lambda function size zip file, which usually creates a hurdle, and it basically reduces the functionality you can have in a Lambda function. Now they have added support with 10 GB allowed containers. So therefore now there can be two kinds of what do you call packages being uploaded to Lambda functions. One is the containers, and the other one previously, which was supported, the zip file. Now the implications of support for containers is quite humongous. If you think about it, what happened was that Kubernetes was formed for orchestrating containers. But the problem with Kubernetes, it has many advantages, especially cloud platform support, because most of the cloud providers provide support for Kubernetes, and that is the main advantage of Kubernetes. But the downside of Kubernetes is that it is comparatively complicated to use, and especially installing is very tough, but using is also not easy. Lambda functions is a very easy solution. AWS had another solution for containers, which was Fargate, of orchestrating containers, Fargate. But now this is the third solution, which is a Lambda function contained in a container. Now containers are everywhere because if you think about it, it is basically a segment, if you got a partition of Linux operating system. And containers, when Docker introduced containers, it basically in the next few years revolutionized packaging of software libraries and applications. Now, if you think about it, the first thing Huma is going to do is introduce us to what is Docker and give us a free small introduction, and then Varis will give a detailed description about Docker and container Lambda functions. Huma, please proceed.
Okay, sir. As you introduced, Docker provided for solution. Let me share something. Okay. So begin with what solution actually container.
Go ahead. Sorry.
What solution container actually provide us is having a view with it. What was happening before containerization was we were using virtualization. Virtualization helped us manage our resources, but there were few problems with virtualization which was actually addressed by container. In virtualization it was very heavy because we used to have a dedicated individual guest OS for each and every virtualized app. But with container engine actually manage this for us, so we do not need dedicated OS for every app. All we need is application binaries and libraries. This makes container very fast, very light, and uh, ideally we can use them for one process per container, and these containers can communicate with each other. With so many containers working around, we need a tool for orchestration as I manage. There are many tools out there. Even Docker has its own native Docker Swarm, but Kubernetes is considered by far the best. Since it's providing so many uses, it becomes complex, as I say. So once we know the basic of container, let's see, for the technology we will be using is Docker. How to work with Docker after installation of Docker engine and all that. All we need is a Docker file. Docker file is like a blueprint where you provide every instruction, your application, your binaries, and all that. Once you have written your Docker file, all you have to do is run a command docker build that makes up your image. That image is your complete package of your application with everything your application needs to run within it mentioned. Once you run that, it becomes a Docker container. Just like a GitHub, we have a Docker registry, Docker hub, where we can build, commit, and push our images, and when we can use them by pulling them, just we do with like GitHub. So with the introduction of a container in Lambda, we can use them for our use, and for that, let's go to Boris. Let me share it. I've stopped the screen. Boris.
Yeah. Okay. Thank you so much, Homa. Let me just share my screen. Okay, so Homa has given us a very nice introduction about Dockers and containers. So I'm going to build up on that. So before actually understanding what containers are and what a Docker is, we first need to understand why do we need to use them? Like what are the kind of problems that we're trying to solve with containers, right? Now to explain that, I've like made a slide in which I've explained a very it's like a very practical example. A very simple practical example. Let's say that I'm making an application, and this is the stack of my application. My application has 3 different services. One is a database, MongoDB. One is a messaging service, and one is user interface, right? So let's say I'm working on Windows. So what we normally do is we download these services and then we install libraries and dependencies for these services. So I'll install my database, I'll install the libraries and dependencies needed to run it. Then I'll do the same for this service and same for this one. So I'll write my code and I'll run it. I'll be happy. Okay, my application is running on Windows. I'm happy. I'm fine. So now I need to send this application to Zeeshan. So I call Zeeshan. I'm like, okay, I've done with my application. Now I'm sending it to you. You can check it. So when I send this application to Zeeshan, it is quite possible that he's using a different operating system, maybe a different version of Windows or maybe Ubuntu or something else. So when he tries to install the libraries and dependencies to run this application, it is quite possible that it would break down or he would get errors. Why? Because all the libraries are not supported on every operating system, and different operating systems can have different versions of libraries, right? And it is quite possible that one of these services is not supported on his operating system at all, right? So for that, he would actually have to change some versions of the libraries. He would have to install some more stuff, some packages. Yep. And it will be very, very time consuming, right? So this is the first kind of problem that can occur. Like whenever you change the environment, probably your application would break, right? And another example would be like let's say that I'm working on the same application, and when I was working on it, I got a notification from MongoDB that we have released a new update, and if you want to install it, you can. So if I try to install that update, that might change some packages in my operating system that were being used by my other services, and therefore it is quite possible that they stop working because of the new version of the dependencies that they were using. So they were actually they only run on the previous versions, but this MongoDB updated my dependencies, and these services don't support the newer versions. So this is also a possibility, right? So why is this happening? This is happening because all my services are working in the same environment, and whenever I make a change in one part of my application, I would have to check my entire application that whether it has been broken or not, right? Why? Because everything is working on the same environment. If one thing changes that environment, I have to make sure that other things are not broken in it. So this is the first problem that can occur. This is called compatibility or dependency issues, right? Now another problem could be that let's say I'm working in a company and we're working on a project, and we hired a new developer. Now this developer wants to run our application, so he would have to install the entire environment, right? He would have to install all the dependencies again. He may have to run like hundreds of commands, and every new developer that joins our team would have to do that. So this is again another problem, very, very time consuming. The third problem is that okay, in a company you have a lot of teams, and one team that is working on the test version of your application might be working on a different environment in a different operating system, and the team that is working on the production version of your application might be working in a different environment. So again, this again is a problem, right? So let's see how can we solve these problems using containers. Containers can actually help us solve these problems. So in this slide, you can see I have packaged my services into different containers. These boxes are containers. Now, if I look at this container has MongoDB inside it, and all the libraries and dependencies required by MongoDB inside it, and even the operating system required by MongoDB inside it. So MongoDB only need this container to run. It is not dependent on the environment, on the external environment now. It does not care about the operating system that is running on the machine. It doesn't care about the dependencies in the machine, because everything is provided in the container with it, right? So all you have to do is run this container, and MongoDB should run fine. And same goes for the other services. So each service is now isolated, and all the and their respective libraries and dependencies are installed in their containers. So they cannot affect each other anymore. In fact, even they're isolated from operating system now. Now, if I send the same thing to Zeeshan, he can run it without any problem. Why? Because even if he's using a different operating system, doesn't really matter, because the operating system required to run these services is installed within their containers, and even all the libraries and dependencies, right? So if I want to change something in this service, I can change its libraries or dependencies or whatever. It would not affect the other containers or other services, right? So this is the advantage of containers. But there's one additional thing you need to do to actually make and manage and use these containers. You have to install a tool called Docker in your operating system. So if I send my application to Sarjishan, he would also have to install Docker in his operating system to be able to run these. Now, these are just few definitions. Containers are isolated environments that can have their own processes, similar to virtual machines. Now, they can be very similar to virtual machines, but they are used very differently. I'll come to that in a moment. So the second point is all containers share the same OS kernel. Now, this is a very important point that I will discuss in the later slides, but just keep this in mind that they share the same OS kernel. And I told you before that they're not dependent on the operating system of your machine. In this case, I told you before that they're not dependent on this operating system, but that is not entirely true. They are somewhat dependent on it. They're using the OS kernel of the operating system of your machine. I'll come to that in a moment. Now, creating these containers can be very hard, like if you do it on your own. But this is where Docker comes in. Docker is actually a tool that allows you to very easily create, use, and manage these containers. Without Docker, it would be very hard, right? Now, this is a bit more detail to help you understand containers better. We first need to understand how do operating systems work, right? So we know that every operating system, I'm not sure if everyone knows this, but every operating system has two components. One is the OS kernel. Uh, uh, where's my mouse? Yeah, one is the OS kernel that communicates directly with the hardware infrastructure of your machine, right? And on that OS kernel, you have a custom software. So these two things make an operating system, right? So I've actually mentioned some of the um, renowned names of the operating system, like Ubuntu, Debian, and Raspbian. So why do we say that all these operating systems are Linux based? Why? Because they share the same OS kernel that is based on Linux, right? The OS kernel is exactly the same in all these operating systems, but the software that is running on top of operating on the OS on top of OS kernel is different for all these operating systems. That's why they are different operating systems. But the OS kernel for all these operating systems is same. That is based on Linux. That's why these are Linux based operating systems. So Windows uh, does not use a Linux based kernel OS kernel, right? It has a different OS kernel. So with this custom software basically has the UI and drivers and a lot of more stuff, which makes them different OS, but they use the same OS kernel that is Linux based. So a Windows operating system also has these two things, but a Windows based operating system would have a different OS kernel, right? Now this is important to understand. Why? Because I told you before in the previous slides that the OS kernel let's say if you're running an operating system inside a container, the OS kernel that operating system would use would come from your machine. Let's say that I'm now I'm working on Ubuntu. Okay, I installed Docker because I wanted to create a container. Now, when I create a container, when I created a container, I want to run Desbin inside it. Desbin is another operating system that uses the Linux-based kernel, right? When I want to run a Desbin inside the container, which is running on Ubuntu, I'm working on Ubuntu. I want to create a container in which I want to run Desbin. I can do that without any problem. Why? Because Desbin also uses the Linux-based OS kernel, right? When I'm saying that I'm going to run an operating system inside my container, I'm saying I'm going to run only some software, not the OS kernel. The OS kernel would always come from the operating system in which the container is running. In this case, the operating system is Ubuntu. So the OS kernel that would be used by the container would come from Ubuntu, which would be Linux-based, right? If I run Debian, I will only have to install this software in the container, and it should work fine because it is compatible with this OS kernel, Linux-based OS kernel. But if I try to make a container inside Ubuntu and try to run Windows inside it, I would not be able to do it. Why? Because the OS kernel of my main operating system is Linux based and Windows does not work on it, right? So I cannot do that. So when I previously said that you can run containers on every operating system, that's not entirely true. It has to be compatible with the OS kernel of your main operating system, right? Now you can actually run container with Windows inside Ubuntu, but for that you have to create a virtual machine that is running Windows, and inside that virtual machine you can run a container that is running Windows, right? But innately you cannot do that. So this was a very important point to understand. So if I make so if I want to run inside Ubuntu, I can do that. But if I want to run a Windows inside container that is running on Ubuntu, I cannot do that unless and until I have a virtual machine. Right now, let's discuss few differences between containers and virtual machines. Uh, can you guys hear me? Am I live?
Yes.
Okay.
Yes.
Okay. So let's discuss few differences between containers and virtual machines. Homa has already discussed them. I'm just going to go through them. So on the right, we have the diagram of containers. So basically, you have this is your local machine. You have hardware infrastructure. On that, you have operating system. It could be Windows, Ubuntu, whatever. And then you install the Docker application, right? And this Docker tool or application allows you to create containers. And these containers will package applications with their libraries and dependencies. And I also told you that you can also run operating systems in them, but not entire operating systems, just this part of the operating system. The OS kernel comes from the main operating system that is running over here, right? But if you look at virtual machines, we have hardware infrastructure that is our machine, right? But on top of that, we have a hypervisor. Now, I will not discuss hypervisor in too much detail because that's off the topic. But hypervisor allows us to create virtual machines. Now, these virtual machines would have applications, libraries, and dependencies, and they would also be running the entire operating systems. So virtual machines are basically running both of these things in an operating system, whereas containers are only running this custom software, right? So you can have virtual machines running on different operating systems. This one might be running on Windows. This one might be running on Ubuntu, right? So basically, the main purpose of virtual machines is to run different operating systems on the same hardware. That is the main purpose of making virtual machines. Whereas the purpose of containers is very different. Containers are used to package and run application in different environments, right? So these are two very different things. So as Homa said, virtual machines are they take a lot of time to boot up. They're bigger in size. They're heavy, right? But containers, they're lightweight. They don't take too much space, and yeah, and then they basically use to package applications. Now, to use containers in your operating system, if you want to practice, you have to first install Docker, as I said before. And in Docker, you would come across two terminologies: containers and images. So images are basically the template of your application. Like in the image, you would define, this is my application code, these are the dependencies, this is I want to run, right? And that is your image. That is not a running application. That is just the image, the code of your application. When you will run an instance of that image, that would be run in a container, and you can run many different instances of your image. So your application would only run when you will run an instance of your image, right? In other words, you can say that that image is your class and containers are your instances of classes, right? So like in this case, whatever I define over here, I can define over here that I want to run MongoDB, I want to install these libraries and dependencies, whatever. And when I will run this image, that would be that would run in a container, and I can run many different instances of this image. This means that this application would be running in there would be many different instances of this application running in different containers, right? So yeah, it is important to understand the difference between the images and containers. Now, let me show you how to install Docker on your PC, because you would need that to run Lambda functions with containers. So sure, yeah, this is the link. So it's docs.docker.com/get-docker. You can just Google it. So there are different versions for different operating systems. I've already installed it, so I'm not going to do it again because it requires you to, I think, restart your computer. So I can't do that right now. But this is how you install Docker. It's just like a normal application, just like any other application. You just have to install it, right? And once you have installed it, you will be able to run and create images and containers. Now, as Homa said, that just like GitHub, in which we have repositories for our code, we also have a repository system for containers, for images, and that is called, it's a very famous one. It's called hub.docker.com, right? So you can see on this website, you have images for many different famous or renowned applications like MongoDB, Ubuntu. You can run Ubuntu inside a container, Python environment, many different things, right? So now, because I have already installed Docker in my machine, I can run. So these are a few commands that you can run in Docker. Now I'll just show you a very simple example that how can you like pull or clone or whatever you want to say an image from this website and run it in a container on my PC. So yeah, I'm gonna run Whalese. I think yeah. So it's a very simple application that just creates this image from text. So let's first clone it. Now, if I go to the commands, the first command is docker run. So this says that it starts the container. So you provide a name of the image with it, and when you run this command, docker run name of the image, it starts the container for that image. And if that image is not present locally in your machine, then it will pull the image from this website and then run it. So let's see. In the documentation of this image, they've already given us this command, docker run, and this is the name of the image. And these are just the parameters, right? So let's run this. As you can see, it says, I'm not sure if you can see this.
Please, can you zoom it a little bit?
Yeah. It says unable to find image locally. Now it's downloading now. It's pulling it from this website. Oh, it's quite a big file. I should have downloaded it before. Okay, so while it's downloading, I'm just going to go through the other commands.
Compared to virtual machines, it's still small, 57 megabytes. Compared to virtual machines were huge because it contained all the operating system code as well.
Yes. So while it's downloading the file, I'm just going to go through this command. So this is the command that we just saw. So after it has been downloaded, when I will run this command again to run this image, it will find it locally because it has been downloaded now. It only pulls it or downloads it for the first time. After that, it runs from a local machine. Then this is the second command. I'm just going to run it over here. This command is docker ps. It lists all the containers. So containers are basically instances of your images. So
increase the zoom, please.
Yeah. So docker.ps lists all the containers. So it lists all the containers that are running right now, right? And if you want to see all the containers that are running and that have been exited, you can run docker psa. You can see this is the history of all the containers that are running in this on this PC. Now, it is important to understand the difference between image and container. Image and container. So this is actually listing all the containers that I ran, right? So like I could have run one image 10 times. That would be 10 different instances of that image, and so therefore it would be listed 10 times over here, right? And then if you want to stop a container, you can write docker stop, then the name of the container. And if you want to remove a container, you can write docker rm and then the name of the container. So then it will remove it from your machine. So right now, most of these has been completed or exited, but they're still present in my machine. I can remove them, like docker rm. I have to write the name. So these are the names. Yeah, I can't read them properly because they're not formatted. But yeah, you have to write your name, the name over here, the name of the Docker over here, and it will get removed. And Docker images basically shows you the list of images that you have on your PC. Still downloading. Okay. You can see it shows. So previously I was seeing the list of all the containers. Now it's showing me list of all the images, right? Yeah, I think I'll have to reduce the font and maximize it to see it properly because it's not formatted. So these are this is the list of all the images. Yeah, I think yeah. So this is the image ID when it was created, the size and the tag. Tag basically tells us some more meta information about the image, like the version. So it says that this is the latest version. And the next command is docker rmi, that is to remove images. So you can find the name of any image over here, and then you can remove it from your machine. And then when you will run docker run again, then it will download that image again. So yeah, these are just some basic commands. I think there are many other commands that you can use with Docker. I think it's almost done. So now after downloading it will automatically run it because I've already used Docker run. Okay, so it has run the application and it drew this this image, and that's it, right? So this is how easy it is. I did not install anything. I didn't have to do anything. It automatically installed all the dependencies, and this is the advantage of containers, right? So
at this point, Varis, your machine is a Linux machine?
no, right now I'm working on Windows. But
Okay.
yeah, I think Windows when you run Linux container or Windows, it automatically creates a virtual machine, Linux virtual machine, and then runs in it. I think so.
I was just pointing
Yeah.
out to students that if you're using Windows, basically it creates a Linux virtual machine and runs the containers on top of that virtual machine. But
Yeah.
if it's a Linux system, that is not required because container support is built into the operating system. And usually by containers, we mean Linux containers.
Okay. So this is how you can use Docker, and you can download many different containers from this website and run them. Now, let's see what are the advantages. Why do we need to use containers with Lambda functions? So the first advantage is that the size that Sarzia talked about in the beginning. So your traditional functions gets compressed into a zip file, and the maximum allowable size for that zip file is 250 MB. But the maximum limit in containers is like 10 GB. That's like so much more than 250 MB. And secondly, it is very easy to test containers locally. So you can also test the traditional Lambda functions locally without deploying them, but you would have to install all the dependencies for that. In Docker, it's very easy to test them locally without even deploying them. And AWS has also given us a very nice tool that I'll show you in a minute, with which you can test your Lambda function without even deploying it. And also it allows, you can also heavily customize your runtime inside the container, right? So these are a few advantages of using containers with Lambda functions. Now let's move to the coding. Okay, before moving to the code, I just want to go through the documentation. So it says over here. So basically, when you will create a container for Lambda function, you will. I'm not exactly sure about this, but I think that you will have to install the Linux environment, the Node.js environment, or the Python environment, or whatever you're working in, and also the runtime API that will allow your Lambda function to communicate with the AWS Lambda service, right? So these three things you need to uh, run in your container with your function handler, right? Now you can either do that manually, or you can use another image inside your image as a base image that is provided by AWS. Like it's an open source image that AWS recommends you to use in your in your Lambda container, right? So this open source image that will run inside our image would take care of everything, like of the Node.js environment, of the runtime API that is responsible for communicating with the AWS Lambda service, and also the Linux environment, right? So we're going to use this open source image provided by AWS as a base image in our image that we're going to create for our Lambda function, and then we only have to add our handler code, and that's it, because the base image that is provided by AWS would take care of everything else, right? Uh, mm, so so you can either download that base image from this Docker hub.docker.com, or AWS also have their own repository, just like this one, a separate repository. Like they have a code commit that is equivalent to GitHub, but they also have ECR that is called Elastic Container Registry that is equivalent to hub.docker.com. That is the repository for containers and for images, right? So you can either download it from there. So they also have some public images over there, or you can download it from hub.docker.com, right? I'm talking about the base image that we're going to use in our Lambda container. Now let's go through the code. The code is extremely simple. Right, so zoom it in. Yeah. So this is a very simple code. We just created a Lambda function, and in the code you can see that we have written Docker image code from asset, and we've given the name of the folder in which we have placed our image, right? So this is our stack. It's very simple, right? Now let's go inside this folder and see what's inside our Docker file. Yeah, so when you create an image, it's called a Docker file, right? So before showing you the Docker file, I'm going to show you the code that we've written for our Lambda function. So this is a very simple code. We've installed a library called random words, and this just creates a random word, and we're returning the random word from our function, and we're also logging the event, right? Very simple code. This is the code for our handler. Okay, this is in a separate file. And then for this, we also have to create a package.json file, right? And in this, we have the random words library that we were using in our main app.js file, right? Now you will create, after this, you will create a Docker file. Now this Docker file actually has all the information about your image. Now you can see we are running 4 different commands over here: from, run, copy, and cmd. Now I think this is like a standard that you always run from command in the beginning of the image. And in the from command, we are saying that we want to get that open source base image that I was talking about, that takes care of everything, the Linux environment, the runtime API, and the Node.js environment, right? So I'm saying over here that, okay, first of all, get that base image from here, from the ECR. So ECR, I told you before, ECR is the repository system of AWS. You can also download it from the Docker Hub, right? So first I'm saying that, okay, make this our base image. By base image, I mean that this would work something similar to, this would work like an operating system for this container, right? Now, then I'm saying copy these files, the app.js file. So we're talking about our a root folder of this file. So the root folder is Lambda image, and I'm saying that in this folder, I want to copy this file, that is our app.js file, and the package.json file, and put them in this folder. And where is this folder? This folder is inside the environment that would be made by this image, right? And why are we putting it inside this folder? Because in the documentation, AWS documentation, they said that they say that your handler code should be present inside this folder, right? Now, if you were making your own environment, like if you were customizing it, then you can like change the directory or whatever. But the open source image that AWS provides us, they say that put your handler code inside this folder, because this is where the runtime is communicating with the code, right? So up till now, we have installed our environment, copied the files for our handler inside this folder, and then we're going to run npm run install, npm install, that will install our dependencies in the package JSON, right? And then the last command is cmd command. So this is like the entry point of your application in the container, right? So where do we want to start from? You want to start from the handler function. And where is that handler function? Inside our app.js file. Right? So we're saying app.handler. We want to start from this. So whenever this container would run, it would start from this function. And this is what we want to do. This is what we want to do, right? We want to run our handler function. So this is a very simple Docker file, right? So now there are some steps that you need to do that are mentioned in our repository. So we have written the code of our handler. Then we have made our Docker file, right? Now these are just 4 commands that we've used over here. I think there are many other commands that you can use to make complex containers, right? So it's saying over here, like right now we are taking the base image from ECR, but if you want to get it from Hub Docker, you can use this, right? To use the image in Hub Docker, I can place the first. It doesn't really matter, right? Now you will have to build your image. So basically, when you build your Docker file, it becomes an image. So this is the name of this is going to be the name of the image, I guess.
What is a little bit screen resolution?
Oh, yeah, sorry. I ran docker build -d random word. Okay, it gave me an error. We'll do so. Let me have a look what's wrong. Let's try to run it in Ubuntu.
What if we are having some problems with your voice?
Can you hear me now? Hello.
It is easy
Hello.
echoing and it's not clear.
I guess for me it was clear.
Hello.
What is, I think, log off, Zoom and come back. Restart your PC and come back.
Okay.
At this moment, while virus is coming back, let me share my thoughts on this. It is a very major improvement that AWS has come up with the Lambda container. But there are some limitations, some things which I don't like. You have to have extend from the base image or create your own image. There is another. I had mentioned that right now containers, the most popular way is Kubernetes of running containers and basically orchestrating them. By orchestration, I mean to start them, stop them, and so on, and how many containers you need. All this is done by Kubernetes. But the other one was Fargate. The problem with Fargate was that you had to have a minimum cluster running. For example, if you have three virtual machines running, and on that machines you run your container. So therefore, it was not actually serverless. Fargate is not actually serverless because all the time your three virtual machines are running, or two, or whatever, maybe 10. Now, in this thing, Lambda containers, the issue is, which I don't like that much, is as a developer, is that you are constrained by their way of doing things. That is AWS. A better solution, in my eyes, at this point in time, is Google Cloud Run. In Google Cloud Run, you don't have to do any customization for Google. They just give it a container, and for example, in AWS container, it tells you which port to listen to, which method will start, how the base image this. In Google Cloud Run is a better solution, but the problem is Google has not provided the infrastructure, or others serverless pieces are not in place. So therefore, if you're looking at standalone container support, Google Cloud Run is much better than either AWS Lambda containers or AWS Fargate. But other pieces of the puzzle are not there. Because AWS has a lot of different serverless services. So therefore, we are going to use AWS Lambda containers. Varis, please continue.
Okay. Can you guys hear me fine now?
Yes.
I think you're still hanging.
I'm still hanging. So Zeeshan can hear me fine.
Not for me.
It's fine.
I think Varis, just to reduce the, please stop your video so that maybe it will reduce the bandwidth requirement.
Okay.
Let's see if just the voice is coming through.
Okay. How's it now? Is it fine? Hello.
It is a little better. Please continue.
Okay. So yeah, I was here at this point where we are going to build our Docker file so that it gets converted into image. Now, the first time I ran this command, it gave me an error. I'm not sure why. Let's try to run it again.
Zeeshan, is Varis sound only weird to me, or is it okay to you, Zeeshan?
Yes, it's okay to me. Video and voice both were perfect.
Okay, go ahead, Varis.
Okay. So the first time I ran this command, it gave me an error. I think it was because of my internet. Let me try it again. So this command would actually build an image from our Docker file. Okay, I did it. And with this name. So the name of our image is random-word, right? So this was our step 4. We created a Docker file and now we have built it. Now we can deploy it as it is because we have built our image. We can deploy this to AWS. But before that, we can also check if our container is working fine or our Lambda function is working fine locally. Now to do that, now the base image that we used in our Docker, this also created a local server inside this container that would allow us to test our function locally. Now to run that server, they have given this command is available in the documentation, AWS documentation. So you can first run a server, and on that server, so when you run that server, you would be able to communicate with the Lambda function, and then you can send requests to a Lambda function through that server, and you would be able to test it, and you can receive the response from the Lambda functions, right? So and I think this only works in Ubuntu because I tried running it in Windows. It did not work properly. So I'm gonna run Ubuntu terminal. Okay, let me just zoom it in. So it says port is already allocated. I'm just going to use another port, maybe 8000. Okay, so this is the server that is running inside our container. And if you send anything on this server, it sends that thing to the Lambda function and then takes the response from the Lambda function and sends back to us. So this is a local way of testing your Lambda function without deploying it. Now I will open another Ubuntu terminal and I will send something to this server. Now this server is running on this terminal, so I cannot do anything on it, right? I cannot use it to send messages to it because the server is running right now. So this again is another command given by AWS in the documentation. I'm just going to copy it. So it's actually sending a request to the server that we just started. So this is the server. I'm just going to put it over here. This is the new terminal. Zoom it in. So I'm just going to change the port number because I changed the port number of the server. That was 8000. Yep. Okay. Now, okay. So if you want to send something in the event, you can send it over here in this in the JSON format. Because I'm also logging the event from my Lambda function, I can send an event over here to see if it's working fine. Just write hello. Or see, this font is quite big for me. Can't really see anything. Okay. Oh. I'm gonna send a request to the server. It gave me an error. Yeah, but the Lambda function ran. It's saying invoke error. Let's try once again. Not sure.
Maybe you add a semicolon after hello world.
Oh,
That's an
okay.
issue.
I'm sorry, the font is too big for me. Let me just copy this command again. Okay, yeah, it worked now because our Lambda function is returning a random word. It returned low. The random word is low. And let's see what has happened inside the function. So it ran. You can see it ran overhead. It gave us the summary build duration. Now we were also logging the event, but in this case, I did not send any event. That's why I did not. I think it logged an empty line or something. Let me just put something here. HW. Hang on. For some reason, I'm not being able to enter the event properly. Okay, now I can see it.
Now I guess you missed a apostrophe after the curly braces.
Oh, okay. Okay, now it's working. Now it should have logged our event. I'm not sure if it did. Yeah. Yeah, I'm not sure what's happening. Yeah, but it's working fine because it's returning us random words. I'm not sure what's happening here. Maybe I think I removed the log console log line, but yeah, I think it's working fine. It's returning what we need it to. Now let's deploy it. right? Npm run build. Now, when we're going to deploy it, it's first going to push our container on the ECR, that is the repository, container repository of AWS. Then Lambda would be using our image from that repository, right? Because we need to save our image somewhere. So you can see it's exporting image. It's pushing it. The push refers to repository. So it's going to create repository with some random name that has CDK assets at the end. And our image would be inside this repository, and our Lambda function would be using the image from this repository. So it has been pushed. Let me open the console. ECR console.
Maris, are you there?
Yeah, so this is,
Yes, okay.
yeah, I'm here. Yeah. So this is the service that I was talking about. This is the repository for containers. It's still deploying. Not sure if it's my internet or what. Let's see if we have, okay, we have got one repository over here. Right. And so this is the URI of the repository. This is the name of the repository. We did not give it any name, so I think this is AWS gave it a name itself. We don't have anything in it yet. I think we're still pushing it. I think I also uploaded the node modules by mistake. I should have deleted this. That's why it's taking a while. Let's just wait for it. Okay, while that is happening, I can just move to step 2 because the code is very simple. Was the second step as well. Okay, so in this, so it is very similar to the previous step. In the previous step, we were directly referencing our Lambda container in the Lambda function. But in this example, we are first creating a repository, and then in the repository we are putting our image, and then in the code we're referencing from ECR, directly from ECR. So this is the difference in both the examples. The rest is same, but the repository would be made in both the examples in exactly the same way, but in this case, we are making the repository first. So you can say, if I want to make a repository manually, like if I go to the ECR and make a repository manually and put a image in it, and then I want to use it in Lambda function, then this is the method to do it. So you can actually remove this line, and then you can just use the repository that you want to, repository and the image that you want to. So in a repository, you can find an image using tag. Okay, but it's taking a lot of time to deploy just one code, so I'm not sure if you would have time to deploy this code. But the procedure is very same. And then you also have to give the permissions to the Lambda function to pull from this repository. I think if you're using L2 construct, you don't have to write this, but yeah, just to be on the safe side. Let's see if we have deployed it. What I can do is I can deploy it again after removing the node modules folder. Yeah, it's taking a lot of time. Oh, okay, it's done. Do we have our image in here yet? Okay, so we have an image. So this is our repository. Inside this repository, we have an image. Now the size is, I think, quite big because I also uploaded the node modules file in this image. That we did not have to. Sorry, node modules folder in this image. Now it's creating our Lambda function. And then our Lambda function would be using this image from this repository. So if I go to the Lambda now, it's creating it. So I might as well deploy the second code as well. Yeah, but it's almost the same. I don't really have to. Yeah, I in fact, I just missed one step. This came in my mind. Now, before deploying your code, you should run this command. And this command just authenticates your Docker CLI with your Amazon ECR registry. I'm not sure why you need to have to do that, but this is also written in the documentation of AWS documentation. So when you run this command, I'll show you. Yeah, so when you run this command, it actually it says login succeeded, right? So have we deployed it? Yep. Okay, it has been deployed now. Now let's have a look at our Lambda function. So you can see we made a Lambda function. Package type is image. Previously, it used to be zip file. Now it's image. Now, one downside is that you cannot view the code over here. Like previously, we could see the code, but it's not possible with the image. But I can test the function, give it an event name. So it will return us a random word. Okay, so it returned us no. Okay, it is also printing the event. I'm not sure why it was not doing it in our local server when we were trying to test it locally. But yeah, this is working. Let me also try and deploy the second example if we have time. So do we have time?
Yes, we have time.
Oh, okay. Because there's one problem in this second example that just came in my mind that I need to discuss with you. You see, here we have first created our repository. And in the Lambda function, we are saying asset.repository. So this references our repository, but in the repository you also have to mention the tag of the image. And what do I mean by tag? If I go back to the yeah. So this is the image tag. This identifies the image inside your repository. So the problem in this second example is that you also have to define the tag, but there's no method in this repository that gives us that tag, right? Yeah, I couldn't. Okay, here we have. Okay, we have it. Image tag to use. No, it's something else. So basically, I tried a lot. I could not find a function that returns a tag. Maybe there is. I couldn't find it. So I right now I've hard coded it. Like I first deployed it, it gave me an error that I could not find this image. So I went to my ECR repository. I copied this tag and then pasted over here, and then pasted over here and then deployed it again, which is not a very good practice. So the tag that you're looking for is going to be in the image asset image.uri. So image.uri also has some other stuff, but at the end of this, there's a string. At the end of the string, you have your tag. So you can either take it out from this string, from this image URL. At the end of image URL, you have a tag. Let me see if I can show you over here. So image URI. So at I think this part is a tag that you need, but there's no function over here from which allows us to that tag. I couldn't find any. Yeah, that's why I've hard coded it right now. But now if I deploy it again, it's gonna get changed because I destroyed my stack. So I'm just gonna leave it blank for now, and I'm gonna get an error. But my repository would be made, and then from the repository, I would take out my tag and hard code it over here. Just delete my old repository. And when you destroy your stack, the repository doesn't get destroyed, doesn't get deleted. So be mindful of that. Right. Now the second step shouldn't take as much time because I have not uploaded the node modules folder with it. But it would give me an error in the end because it would not be able to find the tag because I've removed it. Now in ECR, you also have so you have registries. In registries, you have repositories. You can either have a public. You can either put repositories in a public registry or a private one. And so I think in the public registry, everyone can view it. You also have a public gallery from where I got the base image. Yeah, I think my internet is quite slow. I also retried it a few times. Yeah. Can you guys hear me? Hello?
I can hear you.
Yes, I can also.
Okay. Yeah, I think my internet is quite slow. It's not being able to push it. It's retrying again and again. So yeah,
Varis, I think
we'll end it over here.
we are good enough.
Yeah.
We have covered the main topics and we have shown one example. Don't need to show the second example.
Yeah.
And
Okay.
very well done. Very good job. And let's meet in the next class. Everybody, bye-bye.
Okay, bye-bye.
See you
Bye,
guys
everyone.
in the next class. Bye, everyone.